Download this code from codegive.com, link in the description below. What is caching? Caching is a technique used in computing to store copies of files or data in a temporary storage location for quick access. The primary goal of caching is to improve the speed of data retrieval, reduce latency, and minimize the load on the underlying data sources, such as databases and APIs. When data is requested, the system first checks if it exists in the cache. If it is found, a cache hit, the data is served from the cache, which is significantly faster than fetching it from the original source. If the data is not found, a cache miss, the system retrieves it from the original source, stores a copy in the cache for future requests, and then serves the data. How caching works. 1. Data request. When an application requests data, it first checks the cache. 2. Cache hit. If the data is found in the cache, it is returned immediately. 3. Cache miss. If the data is not found in the cache, it is fetched from the original source, like a database. 4. Storing in cache. After fetching the data, it is stored in the cache for future requests. 5. Expiration policy. Cached data typically has an expiration policy to ensure that stale data is not served. This can be based on time, TTL, time to live, or size, example keeping only the most recent items. 6. Eviction policy. When the cache reaches its storage limit, it must decide which items to remove. Common strategies include least recently used, LRU, first in first out, FIFO, and least frequently used, LFU. Caching example in Python. Let's implement a simple caching mechanism using Python, demonstrating how to cache results of a function that simulates a time-consuming operation, like fetching data from a database. Step 1. Basic function without caching. Step 2. Implementing caching. Now, let's implement a simple caching mechanism using a dictionary. Explanation of the code. 1. Slow underscore function. This function simulates a slow operation by sleeping for 2 seconds before returning data. 2. Cache decorator. This is a simple caching decorator that stores the results of the slow underscore function in a dictionary called cached underscore results. It checks if the param exists in the cache. If it exists, cache hit, it returns the cached value. If it does not exist, cache miss, it calls the slow underscore function, caches the result, and returns it. 3. Example usage. When you call slow underscore function, the first call will take 2 seconds. The second call will return immediately from the cache. Benefits of caching. Performance improvement, reduces the time to retrieve data. Reduced load, less frequent access to the original data source decreases load and can save costs. Scalability, helps applications to handle more requests by serving cached results. Conclusion. Caching is a powerful technique to enhance the performance and efficiency of applications. By storing frequently accessed data in a cache, you can significantly reduce retrieval times and lower the load on your primary data sources. The example provided demonstrates how easy it is to implement a caching mechanism in Python using decorators, but caching strategies can be applied in various programming languages and contexts.